We've mapped our world from the highest mountains to the deepest trenches. We've sent rovers to Mars, and we're peering into the farthest reaches of space. You'd think we have the story of our own planet pretty much figured out, but it turns out we don't. What if I told you there's a lost continent? One that's rewriting Earth's history, and that ancient forces are still carving out our future in ways we're just now starting to grasp. This is a journey into our planet's greatest geological secrets, a story of an Earth that's far more mysterious and alive than we ever imagined, the lost eighth continent. For most of our lives, we've learned there are 7 continents. It's a grade school fact. But what if there's an 8th one, a colossal landmass? One that's been hiding right under our noses? This isn't science fiction, it's the very real story of Zealandia. The idea of a southern continent has been around since Dutch explorer Abel Tasman first sighted New Zealand in 1642, but the mystery took nearly 375 years to solve. For decades, geologists saw the area around New Zealand as just a jumble of underwater plateaus. Interesting, sure, but not a continent. But as more data came in, from rock samples dredged from the seafloor to advanced gravity mapping from satellites, a new picture started to form. This wasn't a random collection of fragments. It was a single, unified landmass almost 1.9 million square miles in size. The evidence became overwhelming. Unlike the oceanic crust around it, Zealandia is made of continental crust. It has the right rocks like granite and sandstone. It's geologically elevated from the ocean floor, and its crust is much thicker. By pretty much every geological standard, it's a continent. There's just one catch. About 94 to 95% of it is sunk beneath the Pacific Ocean. So, how do you lose a continent? The story starts over 80 million years ago, when Zealandia was part of the supercontinent Gondwana, wedged between Antarctica and Australia. As the engine of plate tectonics tore Gondwana apart, Zealandia was pulled away. As it separated, it was stretched, like a piece of pizza dough being pulled in every direction. This stretching thinned its crust, making it less buoyant. It lost its ability to float high on the mantle, and over millions of years it slowly sank, leaving only its highest points. What we know today as New Zealand and New Caledonia sticking out of the water. The confirmation of Zealandia in 2017 is a powerful reminder that our planet still holds secrets on a truly continental scale. The engine of change. But what kind of force is powerful enough to stretch and sink an entire continent? The answer is the engine that drives almost all of geology, plate tectonics. We tend to think of it as continents just drifting around, but the reality is a much more dynamic and powerful process. A planet-wide system driven by immense heat escaping from Earth's interior. For decades, one of the biggest debates in geology was when this all started. When did Earth switch from a static ball of rock to the dynamic world we live on today? Some theories put the date as recently as 1 billion years ago, but incredible new evidence has pushed that timeline way back. Scientists travelled to the Pilbara Craton in Western Australia, home to some of the oldest, best-preserved rocks on Earth. By analysing tiny magnetic minerals locked in rocks that are 3.2 billion years old, they could read Earth's magnetic field. What they found was remarkable. The data suggested these rocks were drifting across the planet's surface at about 2.5 centimeters per year, a rate very similar to modern plate movement. This is some of the oldest and most compelling physical evidence for plate motion ever found, suggesting an early version of plate tectonics was underway just over 1 billion years after the Earth first formed. This discovery doesn't just change a date in a textbook, it fundamentally changes our picture of the early Earth. It suggests that the geological engine that builds mountains, triggers earthquakes, and helps regulate our climate has been active. For most of our planet's history, it's the same force that created and hid Zealandia. And it's still actively reshaping our world right now. A planet tearing itself apart. If plate tectonics created and submerged continents in the past, what is it doing to our world today? To see the answer, you have to look at Africa. Across eastern Africa, a massive geological event is underway. A giant crack, the East African Rift, is slowly tearing the continent in two. This isn't just a fissure, it's the birth of a new plate boundary. For tens of millions of years, the Somali plate in the east has been pulling away from the Nubian plate in the west. The process started at different times in different places, beginning around 22-25 million years ago. In the north and spreading south, today the rift stretches for thousands of kilometers like a giant zipper coming undone. Recent evidence shows this process is happening faster than we realized. In places like the Afar region of Ethiopia, the continental crust has thinned dramatically and is entering a final stage before it breaks apart completely. As the land separates, hot magma rises from the mantle to create new oceanic crust. We can see this happening in what is practically real time. In 2005, a series of fissures and faults opened up. Along a 35-mile stretch in the Ethiopian desert over a matter of days, the result of magma being injected into the crust below. This is how new oceans are born. The Atlantic Ocean formed in a very similar way. When South America and Africa split apart millions of years ago, in a few million years, geologists predict the Indian Ocean will flood into this expanding valley, creating a new ocean basin and splitting Africa apart. Countries like Uganda and Zambia might one day find themselves with brand new coastlines. We are literally watching the first chapter in the story of a new ocean. Understanding these incredible geological forces gives us a new perspective on our world. It's a story of constant change and hidden connections. Speaking of connections, if you're looking to build a powerful connection with your audience online, our sponsor for this video can help. Stick around for a brief message on how they can help you build your own platform. The next supercontinent. So Africa is splitting apart and the Atlantic Ocean is getting wider. If the Earth's surface isn't any bigger, where is all this land going? This brings us to the final and maybe most mind-bending geological mystery: the future. Just as continents break apart, they also come back together. This is the supercontinent cycle, a grand planetary rhythm of assembly and breakup. It seems to repeat roughly every 400 to 600 million years. The most famous example was Pangaea, which existed around 300 million years ago. But Pangaea wasn't the first supercontinent, and it won't be the last. Using supercomputers, geologists can model the current movements of Earth's plates and project them into the future. While these are just predictions, one theory points to an inevitable collision. The Pacific Ocean, the oldest ocean on Earth, is shrinking. Every year it gets a few centimeters smaller as the Pacific plate dives beneath the Americas and Asia. Meanwhile, the Atlantic is widening, pushing North and South America westward. In roughly 200 to 300 million years, many models predict the Pacific Ocean will close entirely. The Americas will collide with a northward drifting Australia and Asia, fusing most of the world's continents. This potential future supercontinent already has a name, Amasia. It's just one of several competing theories, but it's a fascinating possibility. Life on a supercontinent like Amasia would be drastically different. Models suggest sea levels would be lower, and the vast interior would likely be an extreme arid desert, with huge temperature swings. It's a vision of a world completely alien to our own. Yet it's a possible outcome of the forces we see in action today. From the sunken mountains of Zealandia to the growing rift in Africa, it's clear the story of our planet is far from over. The ground beneath our feet isn't static. It's a restless, dynamic system. Continents are born, they vanish, and they're reborn in a cycle that spans billions of years. We live on a planet that is constantly remaking itself, and we're just beginning to uncover its greatest secrets. The Earth isn't just the stage for our story, it's an active main character. What do you think will be the next great geological mystery we uncover? Let us know your theories in the comments below. If you enjoyed this journey into our planet's secrets, be sure to watch our other video on geological wonders. Don't forget to subscribe and hit the notification bell so you never miss an exploration. Thanks for watching.